All right. We are spending an extra day working on the homework packet, so the day is Monday. But that exponent packet, I was away all week, so we're going to answer questions. So first page, you guys, that's pretty self-explanatory. I mean, I think, yeah, I was going to say, do you know what to do with an exponent after you've plugged a number in? Like if we took a look at 9, y cubed minus 2y squared plus 3y minus 4, that would be 5 cubed minus 2 times 5 squared plus 3 times 5 minus 4. Okay, so I'm taking a look at 9 when they gave you a value for the exponent. Now, 5 cubed means 5 times 5 times 5, yes? So 125 minus, right here, PEMDAS, we do the square first. So 5 times 5 is 25, then times it by the 2. 25 times 2 is 50. All right? So from there, it's add and subtract, work from left to right. So work from this side moving over. This is going to be 75 when I work from left to right. Working from left to right, that's going to be 90. And 86 should be your answer for number 9. Double check 9, please. Are we good? Okay, next page. Okay, today you'll examine how to rewrite expressions with exponents in equivalent forms. You'll look for structure and patterns in the equivalent forms in order to write them efficiently. So in these 4, you are supposed to expand. I bet you can figure out what to do with that. Maybe something like this is a little more confusing what to do. X cubed times x cubed. I would go ahead and expand that even more. And then I'd have x times x times x times x times x times x. Okay, any questions on that kind of thing? Let's see, this one looks interesting. If I go expand, I'm going to go 5 times 2m times 2m times 2m. If you left it like that, that's okay, but I would probably go 2 times 2 times 2. 2 times 5 is 10, times 2 is 20, times 2 is 40. So I would go 40 m times m times m. Okay. Let's see. Ms. Wang has just explained to her class how to write simpler expression using the number 1. She wrote the expression at the right of the board. Explain why y6 is simpler than Ms. Wang's starting expression. Oh, I see. So she came from this and looked at the top and bottom as, if I have an x over an x, that's a 1. So do I really need to multiply things by a 1? No, it's the same value without that and that. So if you have exponents on top and bottom, but you can see with the same base pieces that match up. But I don't know if I like Miss Wang's way of doing it. Are these something that you have question on? Okay, so I'm going to get a piece of paper to write these figures. Okay, so x times x times x over x. This is on 165i. I think you can probably see that what we need to do here is 1x over 1x, those can cross cancel out. Or if you were looking at what Miss Wang, the example showed you, is an x over an x is a 1. What you can't do is take that x on the bottom and cancel more than one x on the top. So they cancel 1 for 1. All right, so what's left is x times x, or x squared. Now, a little more tricky is x to the 5y x squared. On a problem like this, we could expand it, okay, and say x this is the long version and may be helpful to understand what needs to happen. 1x here cancels with 1x there. And so I have 2 of them from the top that are left or canceled out. There are 3 x's left over. Now again, that's the long version. Do you notice a pattern here of something that maybe we could do? How does x5, x2, and what's left after we reduce? We're subtracting exponents. When you divide, you're subtracting exponents. So 5 minus 2 is x to the 3. If you look at this one over here, it started out 3x's over 1x and ended up x squared. Notice that happened because 1 for 1, they're canceling each other out. All right, so the x squared on bottom canceled 2 factors of x on the top, but you can subtract exponents. Let's see what we have right here. K3, K5, K squared. One thing to know, when you're multiplying, it's not a subtract. What do you do with the exponents when you're multiplying? You add the exponents. So this is K8 over K2. And then what did we just find out as a pattern when you're dividing? So that's going to be K6. All right, 2 of the K's on the bottom, cancel 2 of the K's on the top. All right. Oh, look at that down below. Woo! Are you loving it? Okay. First of all, these are some multiply problems. And I guess they're saying, oh, look at A right here. Is this too small? Okay, on the 166, H3 times H4 times K, they're saying, is that equal to H12? No, because what is H3 times H4? That should be H7. You add the exponents, and so that does not equal. So in A, this is a no. Okay, let's see what's happening in B. Again, a question mark. Okay, the key to this kind of thing is divide and conquer. Okay, divide up like terms and think about like terms all by itself. If you have 39 over 3, how can we reduce that?
13 over 1.
Divide by 3. Divide by 3 here is 1. Divide by 3 here is 13. So the factor of 3 can come out. I'm going to put 13. I'm going to put over 1. I may not need that 1. You know how 1 underneath is. Now I'm going to just look at the p's and ignore the rest. What do we know about P4 over P2? Subtract, and it's going to be P2. And then just looking at the Q's, what's going to be Q3? 5 subtract 2 is Q3. All of that's over 1, so that's 13P squared Q3. Is that what they were saying? Yes. So whereas this one was a no, B is a yes. Okay. I'm going to not do any more of those. I want you to kind of dig into them. Now that you've seen a little more of this, it sounds like there were questions on this page. So you're going to have time in class to work on that. How about this page? That's more practice. Probably you did good on the top. Oh, there's something interesting here we haven't talked about yet. Take a look at 13. Okay, we've been saying subtract exponents, and so far the effect of that has been our denominators going away. That's not always true. You can still think of this in terms of subtract exponents, but if the bigger exponent is in the bottom of the fraction, leave that variable in the bottom of the fraction. So for example right here, if I'm looking at that P, there's nobody to reduce it with. It's going to be part of my answer. Now again, divide and conquer. I'm going to look at these two M's. One's on top, one's on bottom. One has no exponent. That's an invisible 1. First of all, if we're going to subtract these, I've got 5 minus 1. What's 5 minus 1?
4.
4. Second of all, though, because the 5 was on the bottom, I'm going to put the M4 on the bottom of the fraction. Okay, then I'm going to look at the N and ignore everything else. I've got an N2 on top and an N with an invisible 1 on the bottom. Memo! I've got 2 minus 1. What does that give me? 1. And I'm going to put an N. You can write the 1, but you don't need to. An N without an exponent has an invisible 1. So the one thing that was different here was that this M, the bigger exponent, was on the bottom, so your answer should have the M on the bottom. I'm going to look at 15. So that was 13 on this side. 15. All right. So again, divide and conquer. Look at the numbers first. Tony, what's a number I can divide out of both 12 and 16?
2.
And there's an even bigger number. 4. Okay, you can divide the 2 first and then look at them again and say, can I divide by 2 again? A lot of times 2 is like that. But if you can see that there are actually 2 factors of 2, or 4, divide the 12 by 4 is 3. Divide the 16 by 4 is 4. Now I'm going to look at my H's. First of all, is the answer, Brody, going to be on the top or bottom for the H's?
Top.
Top, why?
Because it has a
bigger exponent. Now, Isabella, I've got H3 and H2. And that's going to give us H. Good. Now I'm going to look at the K's. Okay. Brian, is the K going to be on top or bottom? So K with an invisible 1. That makes this K. So here's your answer to 15. All right. So that may clear up some questions that you may have had here. And you want to go back and look at these carefully and make sure you weren't just putting them all in a line. You have to have, in a lot of these, some on top and some on bottom. Okay, find two fractions equivalent to each. What's a strategy? Yes.
Just double it.
Double it, so 2/8, there's 1. Double that, 4/16, or I heard something else, 4/20, wait.
It's
5/20. Okay, I can't remember. I'm not sure what I heard somebody say. Okay, so multiply the top and bottom by the same thing. If you're doubling it, you're timesing it by 2. You could times it by 3. You could even take this 1/4 and put an x and an x. That's like multiplying it, you know. That doesn't change anything. I could easily take that back out. Okay, so equivalent fractions. Monty completed 18 passes in 30 attempts. What fraction of his passes did Monty complete? Write in simplest form. Okay, so 18 out of 30 was before you reduce. Then they said, oh, I can see that reduces 3/5. If you can see right off the bat that both of those divide by 6, then you can do it in one step. If you divided by 2, you would have got 9/15. Oh, I can see those divide by 3. Both of those divide by 3, 3/5. Okay, so this is simplest form. Sometimes you can see how to get there right away. Let's see, what else in this packet was questionable? Very last page.
Oh yeah, another first page.
Another page?
Yeah, there's the graphic of
This one, this table?
Yeah.
Okay. Using the table, summarize the patterns you found. From each expression in the table below, rewrite the expression in a simpler form. Express that and then write an expression that represents the generalization. Okay, so x to the 25 times x to the 40. Who knows what this is going to be? X to the 65. X to the m times x to the n. What did we do with the 25 and the 40? X to the m plus n. Why is this true? What are we doing here?
combining exponents.
Combine exponents when... How are you supposed to fit it all into that little box? Factors multiply. That's what they want you to do. They want you to answer this, answer it where you don't have a number, where you're just kind of talking about what did you do to get it, and then what were you doing. So for example, here 36, 13, it's a divide problem. Oscar, what do we do with divide? What do we do with the exponents? Not the exponent. Subtract the exponents. So I've got a 36 on top and a 13. Oscar, what happens when you subtract 36 and 13? X to the 23. Okay, so right here, this is going to be x to the m, the one on top, subtract the one on the bottom, and divide, maybe I have to summarize, means subtract exponents. Okay, I made it big for Oscar way back there. Oh, here's in C, this is something we haven't talked about yet. Looks like there's some problems where you needed to do this. This is something totally different. X to the 5th raised to the 12th. I'm going to make a smaller problem. X to the 5th squared. X to the 5th squared is same as x to the 5 times x to the 5, right? That's what squared means. Use this as a factor 2 times. What's this going to be? X to the 10. What do you notice about this 2 and this 5?
So it will be 16.
You multiply them.
We're multiplying. So far we've added in one case, we've subtracted. This is the case where exponents multiply. Okay, so for the what's in C, we have x to the 5 raised to the 12th power. What am I going to do with that 5 and 12? Multiply. What's 5 times 12? X to the 60. Okay, so let me see where you might have needed that. I see it in 173, one problem like that, and in 168. Let's look at 173 first, because it's simpler. So this one, what are we going to have for an exponent? X to the 9. Okay, you could have probably found that by going x to the 3 times x to the 3 times x to the 3 and then adding the exponents. Okay, what's going to happen right here? What's 2 times 4? X to the 8, y to the 8. Okay. Now, the place that's the trickiest is up here, 168, C. That squared, I think expanded version would be easiest to see what's going to happen. (3k5 times 3k5), because there was a 2 for an exponent. Now we're going to multiply 3 times 3. What's 3 times 3? Andy, could you watch me, please? I don't know what you're watching over there. 3 times 3 is 9. K to the 5 times k to the 5. What do I do with the 2 k's? Combine them, but when I'm multiplying, what does that combine? What kind of math do I need to do? K to the 10. When you're multiplying, you add exponents. K10. Okay? What we noticed as a pattern is we can go 5 times 2 to get that 10. But what you also need to notice is it's not just the K that's squared, but that 3 is squared too. That's why I showed it in expanded form. Okay, I think it would be best, or you want to look at the back page? I think there was a lot of questions on this. Otherwise, I think probably you need to go back through, look at it, and I'll walk around and answer questions on the packet. Did you have questions on the back page?
Yes.
Okay. Rewrite each expression below twice. Once using repeated multiplication and the giant 1 to simplify. Again by using your new pattern for division with exponents. Be ready to discuss the meaning of negative exponents with the class. Oh, negative exponents. That'll be interesting. Hello, Miss Marks.
This is for you.
Thank you. Awesome. It is. Thank you. Okay. Okay. I think I'm going to give you a fast forward version. They have two ways that they showed you how to work this. One thing we learned how to do so far, if I have an x with a 4 on top of an x with a 5, what's one way we can look at this? It's what? It's x, but where is that x? 1 over x. It's not 0, it's just on the bottom of the fraction. Here's another way to look at this same thing. If I wanted to not have a fraction anymore, and I wanted that brought up, this is x to the 4 minus 5. What's x to the 4 minus 5? That's x to the negative 1. So here's something that's equivalent. One over x. And I did that 1 over x because when things have a bigger exponent, you can put them on the bottom of a fraction. 5 minus 4, but that's leaving it anchored in the bottom, is 1 over x. Here's another way to look at it. 4 subtract 5. 4 subtract 5. That'll bring it to the top. So if you look at it from the perspective of the top, 4 minus 5. If you look at it from the perspective of the bottom, it's 5 minus 4. Okay, these two things are equal. Negative exponents mean something that's in the bottom of a fraction. That's the key idea here. Negative exponents, something that's in the bottom of the fraction. So, for example, right here, if I did it by our reduce way, 1 over x to the, here I am in b. What's going to happen with these two exponents? If I just leave it in the bottom, it's going to be 4 minus 2. If we go with the pattern of put it on the side with the bigger's in the bottom. What's 4 minus 2? 2. That's one way to look at this problem. Bigger on bottom, I'm going to leave it with my answer with an x on the bottom. Here's the other way. What's 2 minus 4? X to the negative 2. These two things are equal. Negative 2 on top of a fraction or positive 2 on the bottom of a fraction. Okay, I think it'll be best now if I walk around and answer people individual questions on it. If you think you are totally nails, like if I popped down a quiz tomorrow, you could pass it on all of this stuff, then don't look at your packet, work on your stats project. But I think at your tables, why don't you go back through pages and make sure you are on the right page with this, and I'm going to walk around and answer individual questions. Alrighty?